Okay, so we're still working our pool store here, and this time we're talking about size small swimsuits. Okay, so they are $40 each, and you may buy a maximum of 8 swimsuits at this price. Okay, so write a statement using is a function of, using the variables number of swimsuits bought and revenue. So we're really asking which one of these controls the other one. Well, the number of swimsuits bought would control the revenue. So revenue is a function of number of swimsuits bought. So that implies to us that the independent variable is the number of swimsuits, and the dependent variable is the revenue. Okay, so then we need to fill in a table here with number of swimsuits and revenue. Then we're going to graph that on a coordinate plane and answer a couple questions. Okay, so the first one's in there for us. 1 swimsuit would be 40. 2 would cost 80. 3, 120. 4, 160. 5, 200. 6, 240. 7, 280. And 8, 320. So the first point is also already plotted on the graph for us. We're going to add the rest of these. 2 would be at 80. Now this scale here, even though it's not numbered with consistent numbers, the scale is consistent. Each box is 20, and here's 40, 60, 80, 100. 20, 40, 60, 80, 200. So each box represents 20 on the y-axis. So at 2, I would know 80 is here. 3, I need to go to 120. 4, 160. 5, 200. 6 is 240. 7 is 280. And 8 is 320. Now notice these points are in a perfect straight line. That's not an accident or a coincidence or a result of a certain scale. That is because there's a constant rate of change in the revenue. It goes up $40 for every single swimsuit bought. Anytime there is a constant rate of change, your points will be in a line. Okay, so choose any relationship from your table to write in function notation. So, for example, I could pick this point, 3, 120, and function notation means I'm going to say R for revenue of 3 is equal to 120. Okay, so part B says circle the point that correlates to the relationship. So that point would be 3, 120. So 3, 120, I'm circling. Okay, so we did that. So what is the meaning of your ordered pair in context? Whenever you see that phrase in context, it means apply it to what this problem is about. In this case, swimsuits and revenue. Not about X's and Y's or R's and parentheses and function notation, but what it's actually representing real life scenario. So this R of 3 means the revenue, okay, so it stands for revenue if 3 swimsuits are bought is the $120. So should the points on your graph be connected? And explain why or why not. Well, what that's really asking us is, are there more points in between here, in between 1, 40 and 2, 80? Are there points in here? Should these all be plotted as other options? Is 1.5 swimsuits for revenue of $60? Is that an option? Could I have 2.1 swimsuits and an amount of revenue that goes along with that? Well, the answer is no. We can only sell whole swimsuits, not partials, so it wouldn't make any sense to have decimal values or fraction values for swimsuits. And the revenue values are all multiples of 40 because we can only sell, again, a whole swimsuit. So should those points be connected? No. And the reason is we cannot sell a partial swimsuit and all revenue values are multiples of 40. And number 6, look at the graph and what's the meaning of the point 5, 200? Well, we do have 5, 200 right here, and it is in our table. So what is the meaning? Well, just like we did at number 4C, that means apply it to the revenue and the swimsuits. So this time, instead of selling 3 swimsuits and making 120, this means it's the revenue if 5 swimsuits are bought. That revenue is $200. All right, number 7, use the point whose coordinates are 5, 200 to answer the questions below. Which number represents the value of the independent variable? Well, the independent variable is the one that's in control. It's the X value. It's, in this case, the swimsuits. So that's the 5. And which number represents the dependent variable? Well, the value, the revenue resulting from those swimsuit sales are the dependent variable, the Y value, so that's the $200. Write each of the following in words. So R of 3 equals 120. Since that happened to be the point I chose back in number 4, I'm repeating myself here, but this is that the revenue if 3 swimsuits are bought is $120. And likewise then, R of 7 equals 280 means that the revenue if 7 swimsuits are bought is $280. Number 9, we're going to go reverse that. Given statements in words, let's write them in function notation. So if the revenue of 8 swimsuits is $320, that represents R, or is represented by R of 8 equals $320, which again is just another way to write the point 8, $320. Okay. The revenue of 1 swimsuit is bought is $40, so that means R of 1 equals 40. Number 10, the function statement R of 2 equals 80 is represented by what point on the graph? Turning that function notation into coordinate notation, the X is always in the parentheses. It's equal to the Y value, so that is just the point 280. Going the other way, if we take the coordinate notation, turn it into function notation, that's R of the 6 swimsuits equals the $240 revenue. Fill in the blanks with the correct value. Well, if you look back at your little table of values, or just at number 11, R of 6 is 240. R of 4 was 160. And R of what value was 320? Well, if you're looking in the Y column, in the revenue column, for 320, that happened for 8 swimsuits. What do you think that the statement R of X equals 640 means? Does it make sense in the context of the problem? Why or why not? Well, notice there's no value in here. It's sort of leaving it up to us to say, well, what X value? What number of swimsuits would we have to sell to make $640 revenue? So the statement would mean the revenue if X swimsuits are bought is $640. So does it make sense in the context of the problem? Well, it kind of does and it kind of doesn't. According to the sign on at the beginning of the problem, it said only a maximum of 8 swimsuits may be bought at this price. And we found out in our little table that 8 swimsuits would give us $320 revenue, which means that's the maximum. We can't have a value beyond $320. So in that way, no, this would not make sense. However, if we eliminated that limit of 8 and said, let's double that, let's sell 16 swimsuits, and we continued this $40 per pricing, that would result in exactly $640 revenue. So the way you answer this, I guess, would be dependent upon the way you read the question. No, you cannot sell more than 8, so you cannot make revenue of $640. However, if we were allowed to sell more swimsuits, 16 would result in exactly $640 revenue.